we'll be having an introductory part for this orthographic projection of machine components. So once we complete this, later I'll show you using the instruments how we are supposed to draw, and at the same time you must also develop the skill of understanding the drawing. Okay, the actual outcome from this particular topic is that as and when you see the projection of machine components or any drawing, you must be capable of analyzing it and understanding the drawing. So that skill will be developed when you solve more and more problems, keeping in mind the concepts which I'm going to tell you. Okay, so concepts are very simple. All that you need to do is you need to refer more number of drawings. So more the number of drawings you refer and try to solve it, your skill will be developed. The first and foremost part is that many of the time, we'll be using only first angle projection. This is the first angle projection symbol. Okay, so what I'm telling you here, the orthographic views of machine components when we are drawing, commonly we will use first angle projection. It is not mandatory that we have to use first angle all the time. I have told you the difference between first angle and third angle. You must keep that in mind always. Commonly we will use first angle projection. The meaning of ortho itself is 90 degrees. So viewing an object from 90 degrees will be called as orthographic projection. So if you have an object, the line of view should be 90 degrees with respect to the object. So we have the object here standing vertical and the person is viewing it in horizontal direction, right? And when we generate the view drawing of that particular object, viewing it from 90 degrees, we call it as orthographic projections. So here I have another example of viewing an object in a perpendicular way, that is at 90 degrees. This view will be the front view. So there are many views drawn here. I'll just explain everything one by one. This is the front view. This is the observer. This is the right side to the observer, which means that the view that falls here will be the right profile plane. So this plane is right profile plane. So the view that comes on right profile plane will be left side view, which means that viewing the object from the left side. See, if this is the observer, this direction will be left side. Viewing the object from the left, we will get the left side view on the right profile plane. This is the drawing on the plane on the left side. We call this one as left profile plane. Left profile plane, the view will be right side view. Viewing the object from the right side of the observer, this is the observer, and this side is the right side. So viewing the object from the right side, we will get the left side view. Okay, looking the object from the top, we'll get the top view, which we'll draw it here. It's a very simple component here. This is only for your understanding. So you need to look into at least a bit of complex machine components in order to improve your skill. You just need to sit and watch the drawing and analyze it, spending time just by observing it. Okay? So this is the front view, left side view on the right profile plane, and over here is the right side view on the left profile plane. This is the top view and bottom view. So you can see in a sheet of paper how we are supposed to draw all these drawings. All these should be aligned with respect to each other. If you see this line in the front view will be aligned to the bottom view here as well as aligned to the top view here. This is the back view. Because back view cannot be overlapped with the front view, right? Okay. We are writing one on top, one on below, one on the right side, one on the left side. One we are writing exactly on the front view. So the last view, that is a back view, has to be drawn in some other plane. So usually back view will be represented on the right side somewhere here. But back view will be very rarely used. So important thing to note, the different types of lines that you are drawing.
You must make sure that the visible edges are drawn with continuous thick lines. Next, the hidden lines must be drawn with dark dashed lines. And we must make sure that this is differentiated. And the third type of line is the projection line, which should be drawn with thin lines in a continuous way. We can just refer this example and see how the front, side and top views can be drawn from the isometric view. The shaded part with the yellow color in the isometric projection is taken as a front view here, which is drawn in the bottom left. Next, the one that is shaded with the red here will be considered as the right side view, in the isometric projection, which is taken as a side view and drawn in the bottom left as you see in the picture. In the same manner, the top view can also be drawn with the light green color as it is shaded from the isometric projection to the top view as you see in the picture here. And this picture gives us a clear understanding of differentiating the visible, hidden, axis line and projection lines. So keep these things in your mind while you are drawing the orthographic projections and make sure you differentiate the lines properly. Now let us check these three lines with a simple example with this line of sight given in this drawing itself. You see in this picture, the shaded red part will give us the front view. While if you see the top part,
an axis line is at the center and dashed line on the either sides, you must understand it is a circular hole. The same thing goes in the side view. If you come here, you see the dashed line here and an axis line. So which means that this part is actually a circular hole. Now do not get confused that you need to draw it this way. All that you need to draw is only the views. This is how you need to draw, not the 3D views. Okay, this is how you need to draw. You need to draw only 2D views. Okay, so this will be bottom view, this will be top view, this will be left side view on the right profile plane, and this will be left profile plane, and the view that you get here will be right side view. So only the last view that is left out is the back view, which can be drawn here. Okay, this is one example. I just took this for you to get an idea before we get into the problem. Okay, so I have some more examples. So if you observe here, look at this, the left part, this is the isometric view. This will be the question. They will give you the isometric view of the mission component, for which you need to convert it into a 2D views. Whatever they ask in the question, you can see here, draw the front view, left side view and the top view according to first angle projection. So above the line will be front view, that is VP, below the line will be top view, that is HP, and the left side view will be nothing but right profile plane. You just need to understand isometric view and get the front view. Okay, for your better understanding, I'll just show only the front view by hatching or coloring the front face, the surface that will be visible from the front view. Okay, I'll show it to you here. So you can see this circle will be visible. Okay, and this bottom surface will be visible, this one, and even this surface will be visible. Now you can see the front view, what you have already in the solution there. Do you see that? And what are these dotted lines? These dotted lines will represent the hidden edges. You can see very clearly here, we have the dotted edges and we have the axis line 1 and 2. So what are these two called as? These two will be called as circular holes. You must understand by looking at the drawing, when you have the dashed line and the axis line, it is a circular hole, which you see here in the 3D view. Okay, but looking from the front view, that is in this direction, it is not present here on this surface. It is actually present behind that surface. You understand, there are two holes. So this hole is also not on this surface. It is behind that surface. So whenever it is behind, you need to show that with a hidden edge. So we'll see the next example. So this is another component. Again, at this moment there is no need to worry where these components will be used. You just need to think of the drawing. Okay, you can see this surface. Wherever they have given the direction arrow, that direction only you have to take the respective view what is given in the question. So what does this represent? This arrow represents the FV, means front view. So this should be considered as a front view. For example, if they have given this one as FV, you should have taken this side as a front view. Okay, so keep that in mind. According to what is given in the question, you have to go according to it. Okay, so if this is a front view, you can see this surface will be visible, right? And this surface will be visible over here, and this surface will be visible, which you see here. And looking from the front, there is one more surface here which is behind. This is also visible. Why are we drawing this as visible? Because if you observe this, in front of this particular surface, there is no other surface here. There is a cut part. So you can see from here till that surface, there is no obstruction for the view. Okay, since there is no obstruction for the view, this will be also visible in the front view, which should be shown here, which is shown here already. So looking from the left side, that is this one, you can see the side view it is mentioned.
We will be able to get the side view as you see in the picture here. In the same manner, when we observe the top view from this direction, what you see from the top, we will be able to draw the top view as you see in the diagram shown here. So in this way, different orthographic views can be drawn from the given isometric view.